How do disc brakes work in cars and light vehicles? Stopping power unveiled. How disc brakes work in cars and light vehicles. When it comes to road safety, the ability to stop quickly and efficiently is paramount. Disc brakes, a marvel of automotive engineering, have revolutionized the braking systems of cars and light vehicles. These modern braking systems provide reliable and consistent stopping power, contributing significantly to road safety. In this video, we will dive into how disc brakes work, their key components, and why they are the go-to choice for stopping your vehicle. So, before starting the video, please like this video, do subscribe and turn on the notification to our channel for future updates. The basics of disc brakes. Disc brakes are a type of friction brake system commonly used in cars, trucks, and light vehicles. They operate on a relatively straightforward principle: the conversion of kinetic energy, the motion of the vehicle, into thermal energy, heat, through friction. This heat generation results in the slowing down or stopping of the vehicle. Key components of disc brakes. To understand how disc brakes work, let's explore their primary components. Rotor, often referred to as the disc, is a flat, circular metal component that is firmly attached to the vehicle's wheel hub. It is typically made of cast iron, composite materials, or reinforced carbon fiber. The rotor's role is to rotate along with the wheel and provide a surface for the brake pads to make contact. Caliper. The caliper is a U-shaped component that houses the brake pads and fits snugly over the rotor. It is typically made of cast iron or aluminum. Inside the caliper, there are one or more pistons that can move in and out. When hydraulic pressure is applied, the pistons push the brake pads against the rotor, creating friction and initiating the braking process. Brake pads. Brake pads are friction materials, often a mix of various compounds and fibers, that are attached to the inside of the caliper. When hydraulic pressure is applied to the caliper, it forces the brake pads to make contact with the rotor, generating friction and slowing down the wheel's rotation. Hydraulic system. Disc brakes rely on a hydraulic system to transmit the force from the brake pedal to the caliper. When you press the brake pedal, it activates a master cylinder, which sends hydraulic fluid, brake fluid, through brake lines to the caliper. This hydraulic pressure is what ultimately causes the brake pads to clamp onto the rotor. How disc brakes work. The operation of disc brakes can be summarized in a few key steps. Initial contact. When you press the brake pedal, it creates hydraulic pressure in the brake lines. This pressure is transmitted to the caliper, causing the pistons inside the caliper to push the brake pads against the rotor. Friction generation. As the brake pads make contact with the spinning rotor, friction is generated. This friction resists the rotor's motion and starts to slow it down. Heat generation. The friction between the brake pads and rotor generates a significant amount of heat. This heat is a natural byproduct of the braking process. Kinetic energy conversion. The kinetic energy of the moving vehicle is converted into thermal energy, heat, due to the friction between the brake pads and rotor. This conversion causes the rotor's temperature to increase. Slowing down or stopping. The continued application of hydraulic pressure keeps the brake pads in contact with the rotor, effectively slowing down or stopping the vehicle. The process continues until the brake pedal is released. Cooling down. After the brakes are applied and the vehicle comes to a stop, the brake components cool down. This cooling allows the rotor and brake pads to return to their normal operating temperatures. Advantages of disc brakes. Disc brakes offer several advantages that have made them the standard choice for most vehicles. Efficient heat dissipation. Disc brakes are excellent at dissipating heat generated during braking, preventing overheating and brake fade, which can reduce braking effectiveness. Consistent performance. Disc brakes provide consistent and reliable stopping power, making them ideal for various driving conditions and emergency stops. Lower maintenance. They typically require less maintenance than drum brakes and are easier to inspect and service. Improved wet weather performance. Disc brakes perform better in wet conditions, as they are less prone to water buildup and provide more consistent braking. Aesthetics. The visible components of disc brakes, rotors and calipers, often have an appealing appearance, which can enhance the vehicle's visual appeal. In conclusion, Disc brakes are a vital safety component in cars and light vehicles, providing efficient and reliable stopping power. Their straightforward design and operation make them a preferred choice for modern vehicles, ensuring that drivers can stop quickly and safely when needed. Whether you're navigating city streets, cruising on the highway, or driving in adverse weather conditions, disc brakes play a crucial role in keeping you and your passengers safe on the road. What do you think of our video? Let us know in the comments section below. If you enjoyed this video and want to hear from us again, be sure to hit that subscribe button before you go. Thanks for watching.